difficult, right? So you have to convert everything to sine or everything to cos. And the easiest one, is it cos or sine? The easiest one to convert to. Is it to convert to sine or to convert to cos? Mr. Cheng is on the board. Don't look at your paper. To sine. Why not cos? Can you tell me why? Cos will work, right? But why would you say sine is easier? Speak louder. Yeah, we also have for cos 2. Like cos 2x can be written in 3 ways. Cos square minus sine square. 2 cos square minus 1. 1 minus 2 sine square. So on that note, we can do that too. So again, why? Why is it more convenient to change everything to sine? You don't have to convert in 2 sides. One side is already in sine. If you must change to cos, you have to change this to cos. You have to express this in cos. Then you have to have more complicated. So even if it is 5 seconds that has been saved, it is useful in another question. So why give yourself stress? That's the point. So you leave this as 2 sine squared. This must change to sine. So you have 1 minus 2 sine squared. So when these two combines, somebody mistakenly wrote 2 instead of 6. That's why I tell you, take your time to collect the like terms. So while everybody was getting 6, this candidate also knows what he or she was doing, except that just wrote here, instead of adding, the person did subtraction. And then the answer was wrong from that point. You can't afford to lose any 1 point. So from here, sine squared x is equal to 1 over 2, which means sine x is equal to 1 over square root of 2. It should be plus or minus, but I can discard the negative because of this. So I will simply say sine x is equal to 1 over square root of 2 since what? Since 0 is less than x less than pi over 2. That's the reason I'm discarding the other one. Then from here, x is equal to arc sine of 1 over root 2. Looks like some of you don't know trig by hand, by heart. You should know. What angle gives you 1 over root 2? What? You're still looking at the paper. I'm trying to make you think. You're looking at your paper. What angle gives you 1 over 2? 45 degrees. 45 degrees. I'm sure I did a trig of special angles. So if you have forgotten in exam, your equilateral triangle is related to what angle? 60. So your equilateral triangle is of length 2. That's how I derived it that day. So this is 60. In that case, this must be 30. Okay? So sine 60 is this. So when you find this, this is root 3, Pythagoras theorem. That's how I did it then. We were using the classroom downstairs. Okay, refer to those videos if you have forgotten. Sine 60 is root 3 over 2. Cos 60 is 1 over 2. Tan 60 is root 3 over 1. Okay, I'm referring to just one part of the triangle. All you have to do is remember this. So sine 30, opposite 1 over 2. Cos 30, root 3 over 2. Tan 30, 1 over root 3. And for 45, you can only get 45 if you have an isosceles right angle triangle. Right? Something like this. That was the shape I drew, but of side odd unit. So I chose 1 that day. And then I got root 2 here by Pythagoras theorem. And this is 45 degrees. So your sine 45 and cos 45 are the same. That corroborates complementary angle. That sine theta and cos 90 minus theta must be the same. You have to remember some of this stuff. And so this is 45 degrees. But you have to do it in radian. What is 45 in radian? Pi over 4. Or you can use your circular function if you understand that method too. Okay? If I need to review this thing, please tell me. Max scheme says this. You see, change of base, we want to see it. Attempt to use change of base will give you point. Writing that first step correctly will give you point. Simplifying, you see that F is on the left, not in front of it. Okay? A1, then of course getting the final one. When you substitute, yes, you equate both of them, you remove the log, you square both sides, it says all equivalent, which means you can decide to write it another way. As long as at the end of the day you get that. Award 0. If solutions other than x is equal to pi over 4 are included, that means you are not taking note of the range of values, the interval that you are given. So you see, the last one will not be given if this is not the only thing you are showing us. If you are showing us, oh, there are other values. No, you've been given that x lies between 0 and pi over 2. Okay? 5 points. Easy stuff. 7 is a continuous random variable. So this is integration. And some of you did it, integration by part. But the problem was to substitute the values. You have 5 minutes. Oh, can I rush through it because we're on the mark scheme? Okay. So all you have to do is just integration by part. So you let your u, so this is the question. Let your u be this, because this is what we are doing is to find the integral of this between 0 and 3, because of that, right? So you focus on the integration first. In fact, when you are doing it at first, you are welcome not to put the, what's it called, the limits first, until you sorted your integration, that's fine. Okay, because sometimes it can be confusing. So if this is your u, and this is your dv, this is not substitution, because if I let u be this, it won't produce x. But I need something to cancel my x. Who can tell me what can change in this question that will necessitate substitution? How can this question be framed so that I can use integration by substitution? What can change? What do you think? Oh, but if they put this somewhere, then it will be integration by substitution. What is that? We agreed to integration by part, right? And you know why it is not substitution. Can somebody remind me why it is not substitution? Question. It cannot cancel out. I don't know what is it. The x cannot cancel out. If I let this be u, it will not produce x that cancel this out, right? So a question again. Is there a way this question could be framed so that I know that, oh, this is not by part, this is substitution? So that some of us can know next time. If what? It's just adding something somewhere. Come on, quickly, quickly. We have 3 minutes to go. Guys, if this is x squared, if this is x squared, it means it will produce x, which we cancel here. Then it is substitution. It's my lunch duty. Then it will produce x. You have a lot to do, guys. You have a lot. So if you have been playful or whatever, you need to stop it. Otherwise, you won't like the end. You won't like the result at the end of the day. So with your u, you find your du. With your dv, you find your v. X is not of squared, so you can still integrate this easily. So you substitute. Integration by parts. Integral of, you see, this was factorized out. So you are welcome to do that. uv minus integral v du, something like that, and it will produce this. Please try to work it out yourself. If I need to work it out, maybe next time I'll do it. So the first part, you can use apply your limit. You're going to get 0. You are stuck with the last part only. And so you integrate that, it's going to produce this one. This will give you derivative of pi over 6, which will cancel this number that is already here. That's why this is the only thing left. And of course you have some pi outside, I think. Have you checked out? I think there's a pi left somewhere here. Okay? there's a pi over 6. Oh, no. If your integration, you divide by the derivative, right? When you integrate cos, you get sine. Then you divide by derivative of this one. Derivative of this one is pi over 6. So when you divide by the derivative, you are dividing by pi over 6, which means you are multiplying by 6 over pi. So it becomes 36 over pi squared. And you already have pi over 36. So 36 cancel, leaving behind only pi. That's why you have only one pi here. It's better if you work this out. If you just look at the paper, you won't do anything. So I think maybe we continue from here tomorrow. We'll try to rush it for the 2 stuff. We'll continue from here tomorrow. No time. I have to go now. Please bring back the papers.